You breathe in. Your chest feels full, heavy. Your cough rattles up from somewhere deep. What is happening inside your lungs is not what you think. You might imagine a war between the virus and your immune cells. That is only half the story. The real threat can be something your own body is building. Microscopic traps woven from your own DNA. Sticky nets that were supposed to protect you, but they can also suffocate you. Your immune system has a secret weapon. It is called a neutrophil extracellullar trap. A net for short. It is exactly what it sounds like. A mesh made of DNA and toxic proteins. It is cast by neutrophils, your most abundant white blood cells. Normally, NTs are heroes. They snare bacteria and fungi. They stop them from spreading through your tissues. They work beautifully in a cut on your skin or an internal wound. But inside your lungs, during a viral pneumonia, those same traps turn deadly. The script flips. To understand this paradox, we go back to 2004. A biologist named Arturo Zaklinski was watching neutrophils under a microscope. He saw them do something no one expected. They did not just swallow the enemy. They tore themselves open and spewed their DNA outward. That DNA unfurled into a sticky web studded with antimicrobial proteins. Zaklinski and his colleague Volker Brinkmann published this discovery. They called them neutrophil extracellular traps. Before that, science believed neutrophils killed only by eating. Now they saw them commit a form of suicide to cast a net. The process is called netosis. The cell's membrane ruptures. Its inner scaffold of DNA balloons out into the surrounding space. It is a last resort, a desperate all-in move against an invader. Evolution has kept this mechanism for hundreds of millions of years. Now consider what happens when a respiratory virus enters your lungs. Influenza, SARS-CoV-2 RSV. They all target the delicate cells lining your airways. They invade. They replicate. Your body senses the attack and sends a flood of neutrophils. Those neutrophils crawl into the air sacs called alveoli. They arrive expecting a familiar foe, a bacterium, a fungus. But viruses are different. They are smaller and they hide inside your own cells. The neutrophils struggle to grab them, so they do what they are programmed to do. They explode. They cast NETs. And that is where the trouble starts. Think of your lungs' alveoli as millions of tiny balloons. Their walls are thinner than a human hair. Oxygen passes through them into your blood. Carbon dioxide moves out. This exchange keeps you alive. Now imagine those microscopic balloons filling with sticky spiderwebs. The NETs do not just catch viruses. They catch everything. Fluid, mucus, dead cells. They form dense plugs that block the passage of air. Your body's protective mesh becomes a suffocating caulk. Can you feel the weight of that image? A researcher named Paul Kubis at the University of Calgary proved this in a striking way. His team infected mice with influenza and watched the lungs in real time. Neutrophils swarmed in. They cast NX that filled the airways. The tiny breathing passages became so clogged that the mice died from lack of oxygen. The virus itself was not the direct killer. The killer was the immune system's own siege weapon. Paul Kubis described the NX as physical barriers that turn lungs solid. Consider what that means for you, lying in a hospital bed. But the damage goes further. NETs are not inert. They carry enzymes like myeloperoxidase and neutrophil elastase. These enzymes are meant to melt bacteria, but when they spill into lung tissue, they start digesting the very structure of your lungs. They chew through the surfactant that keeps alveoli from collapsing. They burn holes in the thin walls where gas exchange happens. Your blood cannot pick up oxygen. Because the enzymes are sticky, they attract more trouble. Platelets in your blood sense the damage. They clump. Fibrin weaves a clot. The trap grows and hardens. What started as a microscopic net becomes a thrombotic inflammatory mass. In severe cases, entire lobes of your lung turn into a solid cast of immune debris. This condition has a name, acute respiratory distress syndrome, or ARDS. It is the leading cause of death from influenza and from COVID-19, not direct viral damage. Your own body's overreaction. Ask any critical care doctor what they see in the lungs of ARDS patients. They will describe a thick rubbery material that oozes from the airways. It is dense with DNA. When you stand in front of these, it lights up. The very traps that evolved to save you are now drowning you. Now for the twist that makes this even stranger. NETs evolved to fight organisms our ancestors faced for millions of years. Bacteria in a wound. Fungi in the gut. These threats were constant and local. A viral pandemic sweeping through a global population is new. For most of human history, respiratory viruses were limited. They might burn through a village, then die out. Our immune system never evolved a delicate countermeasure for viruses inside the lung. Instead, it relies on the same brute force it uses against everything else. But brute force, in the delicate architecture of the alveoli, is a demolition crew. Your body fights the fire with a flamethrower. There is a second layer to this betrayal. Neutrophils have a kind of memory. They can be trained by past inflammation. If your lungs have been exposed to smoke, pollution, or chronic disease, your neutrophils become jumpy. They are primed for overreaction. When a new virus arrives, they do not just send a few traps, they carpet the area. A study led by immunologist Betsy Barnes in 2020 examined the lungs of COVID-19 patients. Her team found NEATs everywhere in the air sacs and blood vessels. The levels were extraordinary. The amount of NEATs circulating in a patient's blood predicted whether they would survive. High NEAT levels meant a much worse outcome. Your own defense had become a precise measure of your body's spiral toward death. Why does your body not just clean them up? It tries. There is an enzyme in your blood called DNase that chops up DNA. Your body produces it to break down old cells. In normal circumstances, it can dissolve small amounts of NET debris. But during severe pneumonia, the production of NETs overwhelms the cleanup crew. It is like trying to mop a floor while a fire hose is still blasting. The nets accumulate faster than they can be broken down. Your own repair systems are simply outgunned. This leads to a frightening question. Can modern medicine stop this? The answer is complicated. In intensive care units, doctors fight a two-front war. They support your breathing with oxygen, high-flow nasal cannulas, and sometimes mechanical ventilation. But air pressure alone cannot remove the plugs. The nets are sticky and tenacious. Even a ventilator pushing air can struggle to force open the blocked alveoli. So doctors also try to calm your immune system. Steroids like dexamethasone reduce the inflammatory signals that call neutrophils in. Anticoagulants like heparin try to stop the clotting cascade. But there is no approved drug that specifically targets NS without risking serious side effects. If you dissolve all NETs, you might leave your body vulnerable to secondary bacterial infections. Remember, nets still protect you in other parts of the body. It is a precarious balance. You have felt this betrayal, perhaps without knowing its name. That tight, heavy sensation in your chest when a cold moves down into your lungs. The deep, unproductive coughing that leaves you breathless. The overwhelming fatigue that comes not from fighting the virus, but from your body's scorched earth campaign. You are not just sick from the infection. You are sick from your own immune response. Every cough is your body trying to expel the gunk. The mixture of mucus, dead cells, and DNA nets. The stuff you hack up might contain your own NETs. If you put it under a microscope, you could see them. Delicate spiderweb-like structures, beautiful and lethal. Your body's last desperate throw of the dice. The ancient Greeks understood the humors could turn against themselves, but they could not have imagined this. The first line of defense, honed over epochs, becomes the source of mortality in a pandemic. Research teams around the world are now racing to find therapies that gently break down NETs. You may one day take a drug that tells your neutrophils to stay calm, or inhale a fine mist of DNase to clear the webs from your lungs. For now, you are walking around with an ancient biological weapon inside your bones and blood. It works perfectly, until it does not. Think about the next time you feel a tickle in your throat, the first cough that signals something is brewing in your airways. Inside you, a delicate equilibrium holds. Your neutrophils patrol already. They carry the instructions for casting nets, instructions passed down through countless generations, from the earliest mammals to you. They are ready to defend you. But they are also ready to overwhelm you. A slight miscalculation. A virus that evades detection just long enough. Your own cells will begin weaving the trap that can kill you. Breathe in. Your chest feels heavy. And you know what that weight might be. Not just fluid. Not just the virus. The sticky ancient net your own body laid down, designed to catch a ghost, and instead, catching you. If you enjoyed this video, please subscribe to our channel. A new story every week.